Hi, welcome to the demo session for the first week of the Haskell course. Let's look at various administrative matters regarding uh, downloading and running Haskell. As you can see here, this is the Haskell page. Haskell.org is the URL. You go here, you have lots of information about Haskell. In fact, there is even a place where you can write small Haskell programs and run it on the browser itself. There is a lot of information about Haskell. You can see that various features of Haskell is highlighted. You also have various links for learning Haskell. So there is a documentation which is very good really, and you can consult that for learning about Haskell, more about Haskell. Regarding downloading Haskell, on this NPTEL machine I am using Windows. So you have to go to this package manager called Chocolatey, and you can download the Haskell packages. There are multiple Haskell packages available. Choose either Stack Haskell or Haskell Dev, and you can install that. Right, and one other thing is that you must use the terminal for. You must know how to use the terminal on Windows, but I'll try to minimize the usage. On Mac or Linux, you can very easily use this on the terminal. I will be using Visual Studio Code for running Haskell and writing Haskell programs. So if you have Chocolatey, you can download Visual Studio Code as well from that. So I have a Windows PowerShell open here where I have my, if you can see, I have some programs and slides. I have used the Windows terminal to install Chocolatey and the rest, and Visual Studio Code also. There are ways to invoke Visual Studio Code from the terminal or from the menu as you would like. So, okay, so this is about installing Haskell. Here is Visual Studio Code. I have opened the directory with all these programs. In Visual Studio Code, the typical way in which I will be running programs would be to use the terminal. It is useful to move the terminal into editor area, so you have a large terminal. So rather than using the PowerShell or whatever, the terminal program, you can start a terminal inside Visual Studio Code itself. So this is the standard mode in which I will be operating with Haskell. Let me open another terminal just in case. So I have two terminals both in the editor area. So let that be there. Okay, after installing Haskell and the necessary tools, one other thing I would like you to install is something called a Haskell extension for Visual Studio Code. You can install that as well. So you can find various learning resources from the Haskell page itself, but you also have many excellent online books. Here is an online book. As you can see the URL here, learnyouhaskell.github.io. You can say read it online, and yeah, the internet connection seems to be down somehow, but you can go here and read it online. It's an excellent book. You can buy a print version, but you also can read it for free on the browser itself. There are some excellent YouTube playlists. You just go to YouTube and search for, this is one such playlist, Haskell for Imperative Programmers. Here is another by a very distinguished Haskeller, professor who has been working on Haskell for a long time, Graham Hutton, and this is another playlist called Functional Programming in Haskell. Okay, so you can use these playlists to supplement the learning that you have in this class. Graham Hutton has also written a book with the same title, Functional Programming in Haskell, and this playlist sort of walks you through the book, at least some parts of the book. Okay, so this is about reading material. You can go to haskell.org and there are lots of documentation and other reading material available from the web page. Okay, so having said all this, let us actually go and work with Haskell and see how to run Haskell. So far we have seen some lectures where we have seen how to define functions. Let's actually show how to run Haskell. I mentioned GHCI, I also mentioned GHC. We'll look at how to do all this. So let me clear the screen. So you invoke GHCI by going to the command line and just saying GHCI. Yeah, as you can see, it is loading some packages. There is a very decent standard library. The standard library will be loaded the moment you start GHCI, and then you can use various commands. So if you are used to Python, then the GHCI is just like running Python on the interactive shell, or REPL as you call it. REPL stands for read, evaluate, print, loop. What this does is it reads commands that you give. What you give are Haskell commands, or rather not commands but expressions. Okay, 2 plus 5, that's an expression. I hope you can see it. It immediately prints the result 7. That's it. Okay, it reads your expression, it evaluates it, it prints it, and then it is awaiting the next expression from you. So that's why it's called a read, evaluate, print loop. Okay, REPL. So GHCI is the REPL, and for the initial part of the course, we will just be using GHCI. We will write our programs, load it in GHCI, and we will run it. But before loading programs in GHCI, let's look at what all you can do. You can write these expressions. You can write 2 plus 5. You can write 2 star 5. You can write true or false. As you can see, the result is true. What other things can you do? You can write 2 caret 5. The caret stands for exponentiation. This is 2 raised to the 5th power. Right? You can write expressions like this. You can also write more complex expressions, but we will come to that later. You can define functions too. I can say square x. Let us say square x equals x star x. Okay. So now what you are saying is square is a function name. Its argument, let's call it x, and the body of the function is x star x. You can do this, and then you can ask square of 5, square of 125. You can ask various. So you can define functions and you can write expressions which are those functions invoked on specific arguments. Okay, and what else can you do? So you have booleans, true, false, etc. You can try to do XOR true, false. It will complain because it says there is no function XOR defined. Maybe you can define a function XOR here itself. XOR B1 B2 equals B1 not equal to B2. Let's just write that. And then I can ask XOR true, false. XOR false true is also true. How about XOR true true? It should return the value false. XOR false false is also false. Okay, so you can define functions and you can evaluate functions on specific arguments. I can define double. I can use already defined functions in new function definitions. I can say quadruple of x equals double of x. And I can ask quadruple of 5 and I will get the answer 20, right. So you can define functions like this and you can evaluate them. So let me clear the screen. Suppose you try to define a function using pattern matching. We saw in the lecture that you can use pattern matching to define functions. I say XOR false true is false, and now I want to say XOR true false equals false. It is fine, but suppose these are two lines of definitions, but suppose now I ask XOR false true, the value of XOR false true, it will give me an error. So what's happening? What happens is that if I define the same function, whether on the same arguments or different arguments, it overrides the earlier function definition in GHCI. So if you want to write multi-line definitions, remember I am trying to treat this as two lines of definition for the same function. In GHCI I cannot do it unless I enable multi-line definitions. So let us not worry about how to do that, but rather when you want to do this, what you do is you write this program in a file and you load that file. Okay. Here I have a file called week1 program1.hs. There are lots of things in this file, but among other things I have defined XOR b1 b2 equals b1, and all the XOR definitions that we saw in the slides I have written here. You can see here that there is XOR 7, which is a multi-line definition. Now I want to load this file in GHCI and be able to use all these definitions. How do I do that? Let me go back to GHCI. The command for that is load. Load week1 program1.hs. Right? You can see that it has compiled the function week1 program1.hs interpreted. Now you can use all the definitions that have been supplied in the file. They have all been compiled now. I can say XOR 7 of false true. I will get true as an answer. XOR 7 of true false is also true. I can also ask for XOR 17 true false. I will again get false. Yeah, because XOR 17 was a false definition. Let us go there and correct the definition. XOR 17 yeah. Yeah, so this should be not B2, because if it's true I should return false, if it's false I should return true. So I've changed this. Now I can save this, and if I come back here and if I try XOR 17 true false, I again get false because I have not reloaded the program. So the command for that is reload colon. Note that there is a difference between things like load, reload, etc. We prefix them with a colon here, colon load, colon reload, because colon load, colon reload, etc. are not Haskell commands. These are Haskell expressions. XOR, true, false, etc. are Haskell expressions. Reload, load, etc. are administrative instructions that we give to GHCI. So you should say reload. Reload just loads the previously loaded file. Okay. So you don't need to specify a file name when you say reload. Reload just means load again the currently loaded file. But if you want to specifically load it, you say load week1 program1.hs. Load and reload are important things to remember. You can another thing to remember is quit. Okay, that will quit GHCI and go back to your terminal shell. Let me restart GHCI. So colon load, colon reload and colon quit are things to remember. So you needn't write colon load, instead you can just write colon L and that will automatically interpret it as load. Yeah, so now I have loaded the program. Now I can ask for XOR 17 of true false. I should get the answer true, which I am getting now. Okay, so you can load programs and do you can write programs separately and then load them in GHCI and run them. Okay, so let's see what other programs there are. So this file which we will upload onto the resources part of the course is available, and you can download it and play around with it. But we can also add some other functions here. Let's try to define some other functions. So let's try to define a function called power. This is a recursive function. So let's go back to week1 prog1.hs. For the moment, let's say that it works with integer. We'll see the difference between integer and int in a moment. What this function does is power xn will raise x to the nth power. Let's see how we can define this. There are multiple styles of defining. One style which you could use is if n equals 0, then 1, else x times power x n minus 1. That's a definition. Let's save the file and we can reload this. Colon R reloads this file in GHCI. Let's test it on small values. Power 5 2 is 25, power 5 4 625, power 5 8, let's say. You can see the numbers getting larger. Suppose I define it to be int rather than integer. Let's go and change it to int rather than integer. Let me reload. Power 5 8 is fine. Let's try the next power 5 16, let's say. I mean, do we know whether this number is correct or not? Okay, so another important thing you can do in GHCI is to ask for the type of an expression. Colon type of power 5 8 will give you the type of this expression. Of course, we just now said that power is of type int arrow int arrow int. You can also ask for the type of power and let's see what it happens. And as usual, you can write colon t instead of colon type, and I can ask for what is the type of power. It says int arrow int. Good. That's also int. Okay, let's see whether this is the correct answer or not. Let's try power 532. Let's see what happens. Okay. Let's keep going. Yeah, something seems to be wrong, right? Because power 532 is so long, whereas power 564 is also around the same length. But power 565 is power 532 squared, right? So it should be close to double the length of this. What is happening? what is happening is that we are getting very wrong values, and you should already know that you are getting a wrong value because the last digit is 3, right? If you keep multiplying 5 with itself, you can only get 5 as the last digit. So something is wrong. What is wrong? What is wrong is that there is a minimum bound for integers. It is this. There is a maximum bound. You can query the minimum and maximum bounds by saying min bound colon colon int. Colon colon is what is you usually use to denote, you can read it as min bound of type int, max bound of type int. Okay, so colon colon is to indicate that what follows is the type of what happens, what is the expression before. Okay, so this is the minimum integer you can have, and that is the this is the minimum int value you can have, and that is the maximum int value you can have. What is this value? It's actually this 2 power 63 minus 1, you see, is that, and the previous value is minus of 2 power 63. Yeah, so that's this value. Let me clear the screen. Yeah, so you have min bound and max bound. So if you keep multiplying an integer with itself, beyond a point you will get spurious values. Okay, so which is why you have to declare this to be integer. Integer has no bounds theoretically. In practice, integer is bounded by whatever the size of your machine is. Let's get back to GHCI. Let's reload the file and let's try to now ask for the type of power 516. Let's ask for the value of power 516. This is fine because this is smaller than, yeah. Let's try to see what the max bound of integer is. Haskell will complain. It will give an error message which you might not which you might not understand all of it, but at least it is saying that integer is not bounded. Okay, no instance for bounded integer. It is saying integer is not bounded. That's all you need to, that is the main takeaway from this error message. There is no max bound or min bound for integers. So let's try power 5 of 64. Yeah, you can see that really large numbers can be represented as an integer data type. Power 500. You can see that this is even larger. You can even go power 5000 or power 5 10,000. Why not? Let's try power 5 100,000. It takes a while. Why does it take a while? Because you have to multiply 5 with itself. Okay. So of course there are two components to this. One is the amount of time taken to print this large value, but there was a significant delay before it started printing. Okay. Wow, this is such a large number that, okay, so it's here, starting from here all the way down, it's printed power 500,000. Let's try to improve the performance of power 500,000. After all, when you program, you have to also try to program efficiently, right? Not just correctly. So let's try here, and I would like to call it fast power. One way of powering very quickly is to do what is called repeated squaring. we will illustrate that here. Fast power of xn equals, if n is 0 then 1. Let's try to program this in a different style. I'll use guards now. When you add these guards, you have to indent properly. So I'm checking if n is equal to 0. In that case, my value is 1. Otherwise, I want to check if n is even. If n is even, then what I do is I raise x to the power n by 2 and then I square it. Let y equals fast power of n div 2 in y star y. If it's odd, if n is odd, even and odd are two predicates that are defined in Haskell. A predicate in this case is of type int arrow bool or integer arrow bool, and it will return true or false depending on whether the condition is true or not. If you don't want to use this, you can actually explicitly also write this condition. You say mod n2 equals 0. In that case, yeah, you say let y equals fast power div n2 in x star y star y. Yeah, if n is odd, then you do div n2, you raise it, you raise x to the power of that, and then you multiply it with itself, but there is one more factor of x remaining, so you multiply x with that. Okay, so right. Yeah, so this is the new program for fast powering. Let's see if fast power makes our computation quicker. I'll clear the screen. Let me reload. Okay, there are some errors. What is the error? The error seems to be that so it's a silly error. I missed out an x here. Fast power x div n2. Yeah, that should be it. So let me reload the program again. Now it compiles, and let me ask for fast power 100,000, and you can see that it immediately starts printing, right? There is some time it takes to print such a huge number, but it immediately starts to print. Whereas if the same thing with power 5 100,000, it hesitates a bit before it starts to print. Yeah, you see that there is a significant delay before it starts printing, and in fact if you increase the numbers, the delay will only be much larger. Okay, so okay, that's an illustration of how you would do this programming. Okay, so let's write some more programs. Integers and booleans are not the only things that you can work with. You can also work with real numbers or approximations thereof. So there are, let me clear the screen again. There is a built-in function called square root. I can ask for square root of 2 and I get some value like this. It cuts off at some decimal point. I can ask specifically for square root of 2 to be of type float, in which case it will cut down even more. Whereas if I ask for square root of 2 of type double, it will print more decimal digits. Float and double are, float stands for floating point and double stands for double precision. These are terms that come from computer architecture. You don't need to worry about it. Just think that float is some way of representing numbers with decimal points, and double is a way to have more digits after the decimal point. Okay, so note that square root will, even if you give it as an integer as input, it will give a floating point number as output. Let's also, we earlier mentioned that I could do 5/2 and I'll get 2.5. See, you get a decimal number. I can do 2/5 and I'll get 0.4. Whereas if I do div 2/5, I'll get 0. Right? And we have already seen in the lectures that you can, instead of saying div 2/5, you can say 2 div 5. But if you are using div as an operator, you have to enclose it with these back quotes or backticks. Okay, 2 div 5 is 0, 5 div 2 is is 2. Yeah, so there are lots other, it is not just integers and floats and bools, but you can have characters too. I can write my name, Suresh. Yeah, so you write strings by enclosing them in double quotes. You write characters by enclosing them in a single quote. Okay, and actually a string is shorthand for a list of characters. You will see that most of the course will be about, I mean, for the first part, we will be spending many lectures on lists. List is one of the most fundamental data structures in Haskell. Right? If I write a list is written like this, you open the, you write a left square bracket and then you list all the elements interspersed with commas and then you put a right square bracket, and that's a list. And you see that here it's giving you Suresh within double quotes, just means that a string is nothing but a list of characters. And now there are lots of functions on characters also that you can have. Characters are stored in a table internally. Haskell allows Unicode characters, but typically we will be using ASCII characters. You can have some basic functions like ORD of capital S. Okay, it doesn't allow you to do this because there are functions that are specific to character which are not part of the standard library, but you can always import those characters. I can say import data.char. Okay, data.char is a library of functions that Haskell provides for lots of, which contains a lot of basic functionality related to characters. One of the things you can ask is to upper, see, it will change it to uppercase, to upper 1, let's say the character which is this, just the symbol 1, that will just stay 1 because it's not a character in the English alphabet. You can also say 2 lower, capital C. I can ask if something is uppercase or lowercase. Is upper, small c, is false, is upper, capital C is true, right. So, I hope you had a taste of Haskell in this demo session. We will try to have demo sessions each week, and thank you for tuning into this lecture. See you in the next lecture. Thank you. Let me close by quitting GHCI by doing :Q. Okay, thank you.